The first one we see a log by itself equal to a number, right? I have three pieces. It screams, convert to exponential. That's what it's screaming at you. I wish it would. I wish it would like screaming like high-pitched voices. You know? Do not log base 10 both sides on a log. That is not what you will do. That is only for exponentials. Okay, so base of our log becomes the base of our exponent. What's friends doesn't stay friends, so we get 64 equals 4,096 x. Then they're going to divide by 4,096. And some people will type this into their calculators. Now, this won't be the answer they're going to give you. It's excessive. But what we can do is they'll give us an answer 4 to the something. 4,096 is 4 to the what? 6? So we can go 4 to the 64 over 4 to the 6 equals x. And then x equals 4 to the 58. That will be the answer. It would say like 4 to the x or 4 to the y, determine the value of y. So what I told you with exponentials, and I'm not joking, with exponentials, it's and logs, it's not the concepts that are hard, it's sometimes matching their answers that is a little bit difficult. Okay. For this one, I see they want the value of t, so I need to get this. In order to get the value of t, I need to know the value of x, because I can only have one unknown to solve for a known. We've learned that since little, at least grade 10 science, physics in grade 10. That was about all you did in that unit. So I'm going to convert this one first. So I'm going to go the base of 2, what's with it is it friends, so it comes to the base to the exponent of 3 equals x, so x equals 8. Now I can plug 8 in for x, so I get log base 2 of t equals 8. And then I convert again because I have a log by itself with the number on the other side, 3 pieces of information. Base of my log becomes the base of my exponent. What's friends doesn't stay friends, so I get to the power of 8 equals t. And what's 2 to the power of 8? Is it 256? I'm going to guess that, but I wasn't sure. All right. This one, they want the value of b. Log by itself. These are easy questions if you know what to do when you see them. So when you have a log with 3 pieces of information, a log by itself equal to a number, convert to exponential. Log by itself equal to a number, convert to exponential. So often if I could sit beside you and be like, convert to exponential, everyone could do really well on tests. You're like, log base 10 both sides. You're like, oh yeah. And okay, now common base. You're like, oh, okay, cool. It's just like you see and you have to know what you need to do. That's going to be the hardest part of this unit. See, know what to do to solve. Okay? So, base of my log, this is another hint. If the letter or the variable is in the base or the variable is beside the log, the only way you can solve them is converting to exponential. So if the variable's here or here, you're converting to exponential. That's why logs and exponentials kind of have to have the same unit test together. So, base of my log becomes the base of my exponent. Currently, 81 is with it, so 2/3 is going to be my exponent. How do I get rid of 2/3? Raise to the power of?
2.
Yep. 3/2, because when I multiply these, I should get a what? 1. I need a b to the 1, right? So that's why I multiply by the reciprocal, because 2/3 times 3/2 is what? Yes?
Could you also square and then cube root? Would that be fine?
Yep. Yeah, could. So you'd have to undo this though, right? It would be the cube root of b squared, so you'd have to cube it first, then square it, root it.
Yeah.
Like the opposite, yeah. 2/3, right? Because this would be the cube root of b squared, so I'd have to cube it, then square root it.
What do you mean b squared?
If you change this, it would be the cube root of b squared. Like 2/3 is the cube root of b squared.
Oh, yeah.
Yeah, so then you'd have to cube it and then square root it to undo that off of here. Or you could just raise it to 3/2. Okay. So we get, is it 729? You you did the opposite. You got what?
I got 19.
Yeah, so you undid it. So what you would have to do, if you wanted to go the way you were going to do it, totally fine. But this you'd have to change to the cube root of b squared. Do we agree?
Yeah.
Then how do you get rid of the cube? You have to get the cube off first. Cube root off. And to get the cube root off, you'd have to cube it. Right? And now you have b squared equals 81 cubed. And then how do you get rid of the square? B squared. And that gets you 729. I would never go this route. It's way more complicated. If I see a fraction exponent, I just raise it to its reciprocal. But you can do that. It's not wrong.
I don't trust myself to do that.
I just wouldn't do it. But just because it's way more complicated. Okay, now this one. I have log base a of b equals 4.5 and log base a of c equals 3.7. And after today, you might do this question differently. But for today's lesson, you will do it this way. You're going to go a to the 4.5 equals b. And then this one's going to be a to the 3.7 equals c. So now we have log a. B is a to the 4.5. C is a to the 3.7. So that gets us log base a of a to the, what's 4.5 minus 3.7?
Point 0.8.
Yep. And what happens when we get log a to the 0.8? It's 0.8. Because you can do it two ways. Remember, I could say a to the what gets me a to the 0.8, which is 0.8. Or I could drop the 0.8 in front and go log base a of a, which is just 1. Remember, you have to have 0.8. You can't just go 0.8 because on your numeric response boxes on your diploma, there are only decimal spots in the middle 2 boxes. So you have to start with a 0 if the number is decimal. All right, we're going to grab out some paper because we're going to move on to the next little thing. Cafe.
Good man.
All right. So we have went through common base, we went through word problems, we went through solving by conversion to log to exponential and exponential to log. We have went through solving exponentials that we can't convert to a log and that we can't do common base, that we should log base 10 both sides. We went through all of that. So now we're going to do the log laws, which we've talked about already, but we're going to do them anyways.
Oh, the restaurant.
The store? Loblaws is a store, not a restaurant. You know, the fancy restaurant known as Superstore. It's run by Loblaws. It's my favorite restaurant. Okay. So say we've talked about this. So this is log laws, not Loblaws. We talked about this yesterday. If I give you log base 2 of 8, what's my answer? 3. Because you're going 2 to what power gets me 8? 3. Okay, so what if I give you this? Log base 4 of 64. It would also be 3. Because 4 to what power is 64? Okay? Now I want to prove a law to you. So, say I give you log base 2 of 4 plus log base 2 of 8. What is log base 2 of 2? 2. What's log base 2 of 8?
3.
So that gets me an answer of? Okay. We've discussed multiplication rules. And honestly, the people who do really well at logs spot the multiplication and the division rules of logs. So when I have 2 logs added, I can actually put them together by multiplication. When I have 2 logs subtracted, I can put them together by division. That's a rule that we've kind of discussed already. It's the product and quotient rule. Now, the key thing is they have to have 1s in front. So do you see that both of these have 1s in front? If they don't have 1s in front, how could I make it have a 1 in front?
No, you put it as the exponent.
You use the power rule and bring it as an exponent. Then we can put it together in multiplication, or we can put it together by division. Okay? But if I said to you, okay, do you trust me that you can put together two additions to get your multiplication? You'd say yes, because the formula sheet tells me so. But let's show it with actual math. So if I have two logs added, I told you that as long as they're the same base, the key thing here is the base is 2. So if you have a whole bunch of logs with the same base, it screams, put me together. And I'll say that over and over. If you have logs with the same base, it screams, put me together as one log. Okay? So I have log base 2, and then because they have plus 1s in front, they get multiplied. So I get 4 times 8, which gets me log base 2 of 32, which is what answer? Same answer. So that's why it works. Okay? What if I do this one? What's log base 3 of 27? 3, because 3 to what power is 27? 3. Minus log base 3 of 9, 3 to what power is 9? 2. And my answer is 1. Let's use our log laws, not log laws, our log laws. Base 3, it screams, put me together, every single time. If it's base 2, put me together, put me together, every single time. So, this is going to be log base 3. Now, whatever has a plus 1 in front goes in the numerator. Whatever has a minus 1 in front goes in the denominator. So plus 1 in front, 27 goes in the numerator. Both of these had plus 1s in front, so the 4 and 8 both went in the numerator. You see that? Has a minus 1 in front, so 9 goes in the denominator. And now I get log base 3 of 3. And what's the answer to log base 3 of 3? 1. Because it's the same as log base 3 divided by log base 3, which is 1. Or you can say 3 to what power gets me 3, which is 1. Either way, same thing. Okay, what if I make it a little more complex? So if it's numbers, people are like, why wouldn't I just figure it out easily instead of putting them together? Because it won't be just numbers. There will be variables involved. So I have log base A, log base A, log base A. It screams, put me together. A. When all the bases are the same, it screams, put me together. The rules in order to put them together are that they have to have the same base, and the logs have to have a plus or minus 1 in front of them. We agree? Do we have the same base, and do we have plus or minus 1s in front? Yes. So if we have that, we can do it. Just like with transformations, before I say to horizontal translation or a horizontal phase shift, I have to make sure that I have a 1 in front of my x. Or if I log together, I have to make sure I have a 1 in front of my log. It can be a plus or a minus. So I'm going to get log base A. Does the 4 go in the numerator or the denominator?
Numerator.
Numerator, because it's plus 1. 2, numerator or denominator?
Numerator.
6?
Denominator.
What do I do with if there's more than one number in the numerator or denominator?
Multiply.
Multiply. So if I got 2 in the denominator, I'd also still multiply them, right? If I had 2 subtractions, and I had like a 6 and a 4, I'd still multiply them if they're in the denominator or in the numerator. So what do I end up with? Log base A of 8 over 6, which they'll write as log base A of 4 over 3. All right. Make it a little more complex. I'm going to star this one because most people don't spot to put this one together. And the reason why is the moment I don't give a base, it's not as easily noticeable. Like when it's like base A, base A, base A, base A, you're like, okay, I get it. You're saying base A a whole bunch of times. I need to put it together, correct? But when a log doesn't have a base, it doesn't scream as much to put it together. So whenever a log doesn't have a base, I will immediately give it a base because that will help you. And I'm not joking. So if you are given a log and it doesn't have a base, I'm immediately going to put base 10 in. Because then I'll see log base 10, log base 10, log base 10, log base, they're all the same, put them together. Or if you go to convert from a log to an exponential and it doesn't have a base, it's really hard to convert because you have to remember that it has a base you can convert. So the moment a log doesn't have a base, I immediately write in the 10 because it makes everyone have way less chance of having errors. Okay? So I'm like, okay, cool, those are all base 10. I'm going to fix my problem. I'm going to go base 10, base 10, base 10, base 10. And when I start sounding ridiculous, I'm like, okay, wait, they're all base 10. I can put them together. Can I put them together currently how they are? No. And guys, I don't take the sign with me. I only take the number to my power rule. Okay? If you take the sign with you, it'll still work, but it gets really like minusy, minusy, and plusy, plusy kind of things. So I don't ever take the sign with, I just take the number. So I'm taking the 2, I'm plopping it up. I'm taking the 3, it should be inside the bracket. Now do I have plus or minus 1s in front? Yes. So now if it has a plus 1 in front, goes in the numerator. Minus 1 in front, goes in the denominator. If there's more than 1, I multiply it. So I'm going to get an equal sign running down the left because if it's not an equation and you're doing a second step, you're putting an equal sign running down the left because it's an expression and all the expressions equal each other, right? If it's an equation, your equal sign just runs where the equation is. If it's not an equation, you're having left-hand sided equal signs. So I'm going to get log base 10. Sounds like you're saying that to me on the podcast. It was not. He said it to someone else. So it was not to me, podcast people. He didn't tell me to shut up. It was someone else. You're lucky I'm saving you on this one. Bebop. I don't want to say your name because I give it away. I'll you Bebop. Okay, so I have a negative x squared, so the x squared goes in the denominator. I don't have a negative x squared, I have a negative in front. I have a positive in front, so the y cubed goes to the top. I have a negative in front, so the y4 goes to the bottom, and then these two are just multiplied. If you don't show the multiplication symbol for this, you'd luck out. And then a plus 1 in front, so x8 goes in the top. And so I'm left with log base 10 y cubed minus y, or y cubed divided by y4 is y to the negative 1. And then x8 divided by x squared is x to the 6. And if I want to write this out, I would actually write it as
X to the power of 6 equals y.
yeah, and I don't need the log base 10. The other way you can do it when it's these is I don't actually subtract, I just cancel. I'm kind of lazy. So I go like 6, 1, and I have x to the 6 on the top, I have 1 on the bottom. Call it. All right. Now that we went all through that greatness, I wanted to prove to you why the power rule works. Okay, so I proved to you why the multiplication rule works with numbers. I proved to you why the division rule, quotient rule works with numbers, correct? But why does the power rule work? So I'm going to use the example log base 3 of 2 to the 5. So I told you that you can take the number and you can drop it in front, but let's prove why. Okay, we're going to use numbers to prove why. It's not a proof. We're verifying why with numbers. Proof would mean I would not put in numbers. I would use variables. All right. So I'm going to get log base 3. And 2 to the 5 just means 2 times 2 times 2 times 2 times 2. Now, most people are really good at remembering if I have log base A, log base A, log base A, log base A, I can put them together. The rule that people forget about is that I can separate them as well, right? So I can put logs at the same base together, but also if beside it I have multiplications, I can separate them by additions, right? If beside them I have divisions, I can separate them with subtraction. So, because these are all multiplied, I can actually write them as log base 3 of 2 plus 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 log base 3 of 2. Now how many log base 3 of 2's do I have?
5.
So I can just say, well, this is the same as 5 log base 3 of 2's. Now I showed you that if the exponent's in the numerator, or if the number is in the exponent, it can also drop in front because you just have 5 of them, right? Technically. So that's why the power rule works. Because you end up having, when you have it to the 5, you can write it out 5 times. Therefore, you can add it 5 times, then there you can have a number in front. So the power rule works that way. All right. Let's try some stuff. Here's a question for you. The expression log base 5 25m cubed over n where n is greater than 0 and where m and n are greater than 0 is equal to try those two. I'm going to have you star number 1. This is done quite poorly. And the reason why it's done quite poorly is this. When I see the number, I hope you did it all perfectly, and then this is an issue. When I see a number and the m cubed, people will think that they're stuck together and they can never separate. The 25m cubed is sewn together and I can't get it apart. But if I give you an x squared and a y squared, you're like, oh dude, those are separate. This is totally fine. If they're multiplied just as equally as the 25 is multiplied to m cubed. If people do this, I can get 90% of you to not error on the test. If I can get people to put a multiplication dot between those two things, the error rate of this question being wrong on the test drops significantly. Because when you see that there's a multiplication dot between them, you see, hey, they're multiplied. I can separate them by addition. I can separate them by addition when you have that multiplication dot. So if I can get you to put a multiplication dot between there, I reduce the chance of you oopsing big. So I see that those are multiplied. So I'm going to get a plus 1 log in front of them. So I'm going to get a log base 5 of 25 plus log base 5 of m cubed. And then on the bottom, I have an n, so I'm going to minus log base 5 of n. Do you see how you have to realize that those can be separated? And that's the hardest sell for me. So if I get people to put a multiplication dot, they'll separate them. If I don't get them to do it, the error can happen where they think they're stuck together, like sewn together. And they're not. What is log base 5 of 25? 2, because 5 squared is 25. And then I can drop the 3 in front. So I can get 3 log base 5 of m minus log base 5 of n. With an equal sign running down the side. What you see? Do you see how putting the multiplication dot can help? Okay. The next one, I need to change, anytime I see a square root, I need to change it to not a square root. I'm also going to have to do that in calculus, just so you know. Because in order to find a derivative of anything with a square root, we need to make it a rational exponent. So actually, grade 10 rational exponents was so important, you just didn't know it. Like if I could go into the grade 10 class and be like, you are going to use this all the time. Listen. Take it again. Very well. Okay? So, this is a to the 1. So what can I rewrite that as? Log base a of a. Now what is this b root of a the same as?
1 over b.
1 over b, because I can just drop the b underneath, right? So I get 1 over b. So what's my answer to log base a of a to the 1 over b?
1 over b.
1 over b. Because when I sound ridiculous, like a to the blah, it's always the blah. That's the answer. B to the blah. The blah is the answer, right? If you don't remember that, you can just take that and drop it in front. 1 over b, log base a of a, which turns out to be 1. So then it would be 1 over b. That doesn't look like a b, but it is. That didn't get any better. Now it looks like a foot. Okay. 3, it's a boot for b. Good. Okay. I want you to tell me what this is equivalent to. 3 log base x of 4 plus log base x of 8 minus a quarter log base x of 16 So you're telling me what these are all equal to. Okay. I know I may not have given you enough time, but I want to be able to get through it. So this one, they're all base x, so a screen put me together. But the 3 needs to join up here, and the quarter needs to join here. And then we get, so we get log base x of 64 plus log base x of 8 minus log base x of the 4th root of 16, which is 2. And so when I put them together, I get log base x of 64 in the numerator times 8 in the numerator divided by 2 in the numerator. And what do I get when I go 64 times 8 divided by 2? Star this baby. Because I know that if I have 8 to the 5, I can replace it with 7. I know if I have 8 to the 3, I can replace it with 8. But I have 8 to the 75. Can I make 75 be 5s and 3s?
Yes.
What can I make it be? Log base A of 5 times 5 times 3 times A squared. And now I can separate them. This one is done poorly, just so you know.
So just something that I want to ask about the question. If you were to focus on the other part of it, when it says that log base A of 5 is 7 and log base A of 3 is 8, A ends up being 2 completely different numbers. Yeah. So is that an issue with the question, or are we just supposed to ignore that?
I think you should ignore that.
So that's just there to get this.
That's just, it's just the question's not great. So it'll usually be like 6 to the 5 or 7 to whatever, and then it'll make it be like an x. So you'll get log base A of 5 plus log base A of 5 plus log base, they'll usually base A and base B, just so you know, of 3 plus log base A of A squared. And so you'll get 7 plus 8 plus, what's this?
2.
2. Good one. So you get 14, 15, 16 plus 8 is 24. Your homework, don't forget to write this down. We'll go through this one tomorrow. Your homework is page 400.
Jenna McDonald to the front office, please.